Okay, so I thought I would go through just this problem 3 because in lecture we did talk about the topic oil-based mud contamination. But not in any great detail. And you know, often I'll write equations and they're basically right, but I'll forget the index here or there. And so I wanted to talk a little bit about this with you to make sure it's clear what should be done. And so there's an Excel sheet that goes together with the problem. I can just read through it. When drilling with oil-based mud, the collected fluid samples are often contaminated by hydrocarbons originating from the oil-based mud. To obtain a proper measure of the in situ reservoir fluid, the sample composition needs to be decontaminated. And I kind of argue that that can be done very accurately. That's what I said. Generally speaking, that's the case. So in making this problem, I went back to a publication that I actually used when I first got started here in Norway, and that was actually data that was used in the first paper that I wrote on describing the heavy ends of petroleum mixtures. And that paper gives actual data for a reservoir oil with a gas cap, and so it gives the composition. They sampled from the gas cap, they sampled from the oil, they give all the detailed compositions, and of course they weren't using this kind of tool back then, but we're trying to construct with the in situ reservoir sample compositions that they gave, what would a sample today look like if it was contaminated? Okay, so that's what this problem is about. And in the first problem, we're going to take a look. There's an Excel sheet that's provided with the problem, which you can use as a starting point for solving the problem. Get this to work. Okay, so this is the sheet. So this oil-based mud is some oil-based mud I picked from some project I've worked on around the world. It gives the molecular weight of the components. You can see that the first component with any measurable amount is about C10, and the last component with any measurable amount, these are in weight fractions, and to the right is mole percent, but basically down to C26. So from C10 to C26 you have some measurable amount of hydrocarbon in this oil-based mud, in the oil that's in the mud. Okay? And there's a picture of that in a figure form that illustrates how I want you to make your figures. Okay? You can see, can you read the, at least here, you can read the text as from afar. It's because I'm using 16 point fonts here. 14. If it went to 16, you would be even better in terms of seeing. So that is 16 on that one. It's a bit strange. It looks like different sizes. Am I doing something wrong?
Different font type.
Oh, different font type. Okay, this is Arial. All right, so Arial is kind of a standard, so I'll just, that should be probably the standard. So I don't know how Arial got in here, but okay, so you can see that, and that's probably also needs to be a little bit bigger for you to see it. Okay, can you guys see it in the back okay? But not better than you kind of need to. So basically 16 points better. You should be able to see everything. Anyway, the amounts, this is in mole percent, so that's the first or the second column, I guess, here. Mole percent there. You can kind of see it looks like a hump. Okay, and then there's a in this surface sample. This is actually the sample composition collected from this that's presented in this paper of the reservoir oil. So we've kind of got I don't know exactly what the reservoir looks like, but it's let's just make it look like an idealized reservoir. You've got some oil, maybe give more oil than gas. Back in the paper's from 1953, so that's even before I'm born. So basically we've got a sample down here, so they probably had a well. Maybe it was perforated down here, and they collected samples from a testing system. They recombined those samples to come up with this composition of what I call the reservoir oil. Okay? I'll make this just a little bit bigger so you can see it. Okay, so that's our reservoir oil sample, and that's the set of compositions. What I say, surface samples, it's of the reservoir oil. The molecular weights are given here for the heavier components, and they actually did measurements of molecular weight and specific gravity using some special techniques even back in 1953. There's more distillation and chromatographic analysis, and so these are the compositions given. And then basically what you're supposed to do in this problem is to take and say, if you went in today and did a sample of this reservoir, assuming it had never been produced, and you drilled with oil-based mud, and you got a contamination level chosen arbitrarily to be 32 weight percent, 32 weight percent on the basis of the C7 plus, and that's normally how the lab reports this. Okay? They don't say that there's so many percent of the reservoir fluid is oil-based mud. They say that if you flash, as we talked about on Tuesday when we measure the composition, if you flash it down and you get this flashed oil, they do this whole analysis of what's contamination on the flashed oil. Because in the flash gas, there's basically no oil-based mud components. They're too heavy. So what they do is that they take the flashed oil, which is essentially C7 plus, and they say that of the flashed oil, some weight percent is oil-based mud. Okay, that's the way they report it in the laboratory. And the number might range from, like I said, 1% to 40%. So I've given you a big number here. Now, when you write the Excel sheet to solve this problem, that number 32 will be in some cell. It'll be in red or whatever your favorite color is, indicating that you can change that number, and your whole analysis will calculate anew. Okay, and what we're interested in is looking at this in situ reservoir composition, particularly the heavy ends, C7 and heavier, how it looks with no contamination. We've given you that composition here in Excel. This has got no contamination. What would it look like if we add some amount of contamination? And just so that everybody has a common number, we're using 34 weight percent. Okay. So you're going to have to basically mix together the oil-based mud and the surface sample in some proportion, 34%, 66%, okay, on a weight basis. So you have to have weight fractions of the reservoir oil, which you don't have, okay. You got to convert to weight fractions also. And then you just do this mixing, but it's on the C7 plus basis. So you need basically a column for the reservoir sample weight fractions, and then you can do just isolate only the C7 plus fractions. And then recombine the two together. And then we're interested in what is the composition that you expect for the entire sample if you had that level of contamination. How would it look different? Okay, so that's the first problem. I'll tell you a little bit more about how to solve it. So you've got this is the reservoir oil composition. That's a molar composition. Z is for molar. Okay, that's given. We've got the oil-based mud composition, which I'll write like this. That's also on the molar basis. We also have on a weight basis, oil-based mud. That's also given. This is for I for all components. Okay. So we're going to need to translate the molar amount to, well, we're going to calculate masses from that, because what we want is a set of weight fractions for the reservoir oil. Okay. That's straightforward. That's the mass, the reservoir oil for component I, over the total mass for the whole reservoir oil. That would just be the sum of all the masses of all the components. And the mass is given by, we have the mole fraction. So we have what's the relation to get mass? If we say we have 1 mole of the mixture, we've got, that's the moles of component I divided by, or not divided by, but multiplied by molecular weight of the component. That gives you the mass of that component, right? That's pretty straightforward, and it's just the sum of all of those. That's the total mass for J equals 1 to N. Same thing. ZrOJ times its molecular weight. So you just make a column of this term here is essentially the mass, right? Just make a column of the mass. And then you can divide and make a new column where you get the weight fractions. Okay. So you're going to need to do that. Well, you don't really need to do this, but I'm going to have you do this. Okay. And then what I want you to do is to take the weight fractions and put it on a C7 plus basis. What that means is that you basically create a new stream that just throws away everything that's lighter than C7. Okay? And you want it to normalize to, for example, to 1. Okay? So you go on a C7 plus basis, and I'm going to call this we don't need mole fractions here, but weight fractions. Weight fractions with a hat, okay? And that basically just means that we're going to take the weight fraction of that component, I, in the total mixture, and we're going to divide by the sum of the weight fractions for all of the components J from 7 to whatever the last component is. We're only going to consider the C7 plus. So now this thing here will normalize, it will sum to 1, right? And it'll only be calculations for C7, C8, C9 down, okay? So we calculate this by computing 2 columns. That's 1 column. And then the whole thing is another column. Then we get these weight fractions on a C7 plus basis. Now the oil-based mud only contains C7 heavier materials. It starts at C10, so it already is a C7 plus, right? There is no light stuff in the oil-based mud. Okay. So this is the reservoir oil on a C7 plus basis. Now the lab says that we have 34 weight percent oil-based mud in the C7 plus material. So what does that mean? Okay, what does that mean? This is going to be in some lab report that you pull out. This is your job, you remember. They gave you the job, you don't really, maybe you like it, maybe you don't, but so they gave you this report, and it's on a weight percent oil-based mud. So what does that mean? That means that 0.34 is the mass of the oil-based mud in the C7 plus of our sample mixture. Our MDT, or our sample mixture. Divided by that same oil-based mud, C7 plus the mass of the reservoir oil. I don't know what symbol we're going to give this, but that's what it's calling. It's basically saying that if we took our oil-based mud and we had 34 grams of that, okay, in the laboratory, and we had this flashed oil, which I'm going to say just ends up being only C7 plus components, okay? So we've got this this is basically the C7 plus in the flashed oil. Okay. Let's just say that the flashed oil, all the C6 and lighter components go into the flash gas, just to make it. So we're sitting there in the lab with this flashed oil. We take 66 grams of that sample. We add it to 34 grams of the oil-based mud, and we get our mixture, which is 100 grams. And that's our C7 plus stuff in the sampled MDT mixture. Okay? That's 100 grams. Have I lost anybody? So we can calculate in the, just going to call it MDT sample, even though I shouldn't. In the MDT sample, and the C7 plus material of that, we have a weight composition, and I'm just going to call it MDT, and the C7 plus part, component I, is just going to be this 34%, 0.34, times the weight fraction in the oil-based mud, component I, plus the 66% weight fraction normalized reservoir oil. Okay. Because this normalized, this hat, is basically saying that's just the C7 plus part.
In this calculation, when you will be calculating this WROI,
Yeah.
with the head, so
Yeah. So this will be in this MDT sample, if we actually had an MDT sample, we flashed it down to a C7 plus mixture only, and you can actually do that. Core laboratories, they used to do it that way. They'd actually distill off all the C6 and lighter stuff, and they would be left with a flashed down C7 plus material. So in that flash material, they will only have C7 plus in this MDT sample we collected. And the composition of that sample would be this. Okay? Then you can calculate from this, you can calculate the maybe what we should do here, we should put this hat like that. It's because it's only the C7 plus material. Or just for consistency, I'll write it that way. That means it's a C7 plus only. We can calculate the flashed oil mole percentage. Again, this is just C7 plus, but on a molar basis. Okay? So how do you do that? We've got the weight fractions now. So we have to convert the weight fractions to mole fractions. Okay, so I'm not going to go through that. You basically, you know, you need to do that. You need your weight fractions and the molecular weights. Okay. Now the molecular weights for the oil-based mud are slightly different than the molecular weights. Here's for the oil-based mud, and here are the molecular weights for the for this reservoir oil. Don't worry about the difference. You can do it completely correct if you want. You can actually calculate what's the average molecular weight of C15, but don't worry about that. Just you can calculate the average. This would be the average of the oil-based mud and the reservoir oil, but I'm just going to say simplify, just use the molecular weights of the reservoir oil components. Okay, you don't need to go calculate the this average. Okay, so just say that that's approximately equal to the values of molecular weights given for the reservoir oil. So now the tricky part comes. Now the tricky part comes. How to get the molar composition of what we actually sample. That's what we're looking for. Okay. That's what composition do you expect the MDT oil sample to have? That's what you're looking for. Okay? What you have is this mole fraction on the C7 plus basis. You could call it the... What we do have is this X. This is of our flashed oil from the MDT sample. Okay, we collect the MDT sample, we flash it down, and we get these mole fractions. And we're saying that the flashed oil, it's only C7 plus. Okay, that means that the flash gas is all the C6 and lighter stuff. Okay. Well, this thing here, this what we're looking for, is some amount of the flashed oil and some amount of the flash gas composition, right? This is the flash gas. C6 and lighter components. I'll write this a little bit different to be consistent with what we looked at yesterday. This is the flash gas composition. This is basically the flashed oil composition based on what we looked at Tuesday from the MDT sample. And we have to know kind of how much of each of these we have. So what we're looking for is this. It's equal to the mole fraction that becomes this flash gas from the MDT sample times this composition here, which we haven't said where we're going to get that, plus 1 minus Fg times this composition that we have up here, which is just what we calculated here. So the problem is that we don't know what is the mole fraction of the C6 and lighter, the mole fractions of that, and we don't know this amount Fg. Okay? All right? That's going to be the challenge for you to figure out. How many don't like mystery TV programs like Agatha Christie? How many do not like Agatha? How many always figure out who killed? How many always figure out who killed the victim before Agatha or before Miss Marple or Poirot? How many always figure it out? See, you got one back there. We're going to test him. Okay. Okay. To solve this, you're going to have to be a little bit inquisitive about what do I know? How can I figure it out? Okay, it's a little bit like that. Okay? Does anybody see how to solve this? Immediately. Okay, you're a little bit in the midway through the TV series. we're midway through. We know a little bit. Curtis has been giving us a little information. I generally, even at the end of the program, don't understand why the person killed. They always know something that they didn't tell you along the way, or I fell asleep. So it's kind of like I still don't understand at the very end. Some of you may end up being that way. Well, you're going to have to try to figure out how much gas and what is its composition. If you get that, the rest of it should be okay, because basically I've explained how to get the, this C7 plus based reservoir oil composition on a weight basis. So I've gone through that. So this should be okay. You should be able to follow down to here. And what we're saying is that that is basically our flashed composition of oil if we took our MDT sample and we flashed it down. That would be our normalized composition. So we have that. Okay.
So when we flash this MDT sample, so in the oil we get, after the flashing, we get zero methane.
That's right. Because what I'm saying is, and actually core laboratories used to do their flash in the flash GC recombination back in the 1970s and 60s. What they actually did, they did the flash down to 1 atmosphere, okay? And then they took that resulting oil and they boiled off to the normal boiling point of C7. All the stuff, or maybe C6, I don't know, whatever it would be. So that not only the flash gas, but they also boiled off the C3, 4, 5, and 6 that was still in that flashed oil. They boiled it off, put it together with the flash gas. So they got a clean break in the flashed oil. It was only C7 plus. That was the procedure. So you can actually do that experimentally. So we're going to consider our flashed oil to be pure C7 plus. And our flash gas, accordingly, is pure C6 minus. Okay.
But when they flash this MDT sample, they don't measure the gas composition.
They do, but we don't have that. We're trying to construct this only knowing the in situ reservoir composition. Okay? We're trying to construct what would the MDT sample look like. Okay? We know the reservoir oil composition. We know the oil-based mud composition. Now, we could do this calculation differently. We could also calculate this in the following way. We could take this composition, right, which we have given, times the fraction, well, let's move this over here. We could take the oil-based mud composition here, which we're given, times what I'm going to call, did I use that somewhere else or not? FOBM. The 0.34 number. I didn't give it a value. Yeah, so I didn't give it a value. So this would have to be the moles of oil-based mud over the moles of oil-based mud plus the moles of reservoir oil. Okay? That would have to be its definition. Okay? Basically, if we take the mole fractions of the oil-based mud times the moles that were collected, I'm just going to write it on this way so that I can have a single unknown. So we're given this, and we're given this in the tables. Okay? But what is this? So we have two ways to do the calculation to get the answer. But we're not given this directly. What are we given? We're giving that 34% on the C7 plus basis up here. We're given this. So we're given this mass ratio, the mass of the oil-based mud and the C7 plus over the mass of oil-based mud and so forth. So we're given this. And I don't know what we want to call this. We can call this basically this, meaning that it's on a C7 plus basis, oil-based mud, and it's on a weight percent basis. So there's two ways to solve this crime. The one way is to figure out, if I know this, can I get this directly? Okay? So is there a relationship between this and what I called oil-based mud, hat, weight percent? It's terrible, I realize. Okay, that's 34%. That's what the lab gives you. Is there any way I can, in a clever way, based on this, figure out what this is? That would be one way to solve the mystery. But another way to solve the mystery would be to figure out what is the FG in what the laboratory, if they did the sample and they flashed it down, what FG would they get? And what would be the composition of that flash gas? Now it's a little more complicated, a little more interesting. So if you're into solving these mysteries, you can either cheat while the spouse is laying on the couch sleeping. You fast forward, you figure out who killed, and then you rewind back, and then you wake her up and say, "Let's watch." Say, "I think it was John that killed," and then at the end, that's cheating. Okay. So there's two ways to solve this problem. And again, it's really just accounting, keeping track of molecules. It really is all it is. It's not like brain science or brain surgery or something we're going to get a Nobel Prize for, right? But it's still not trivial. It's kind of a complicated way to do stuff we learn in chemistry, keeping track of moles. So make that an enjoyable kind of task and try to figure out one way or the other of solving for that composition. Okay? Now the second problem is that we're given such a contaminated MDT sample up here. We drill a new well in 2015 and we basically collect an MDT sample of the reservoir gas. Okay? And I'm going to call that basically MDT composition. That's what we collected. And this is for the reservoir gas. That's what's given over here in column I. It's the same oil-based mud. Okay? Same oil-based mud. So the problem is, given that contaminated composition, determine the oil-based mud contamination level graphically. Report the answer both on a mole percent basis, that's what we're talking about down here, this one here, and on a C7 plus weight percent basis, which has got this, okay? Both. Now, this one is a fairly straightforward on this reservoir gas problem, because we basically have that the MDT sample of the reservoir gas is just the composition of the reservoir gas, okay, times 1 minus oil-based mud, that number there, plus the oil-based mud composition times FOBM, okay? We're given this, and from the lecture last week, I think, what we talked about is that, primarily you can just plot mole percent here. And for practical purposes, you only need to look at, you can plot it versus molecular weight or single carbon number I. It doesn't really matter, whatever you like on here. And just start it at C7. And what you want to do is that you want to guess this number here, and then you back calculate from this Z or GI. Okay, that's just simple algebra. Okay, that's like the crime for little kids. Okay, you just solve that. Now when you do that, you're looking to, you basically want this to be a smooth, probably a continuous, meaning no hump, no valley, compositional trend. So we basically want the C7, C8, C9, C10. There is no oil-based mud. So this is always going to look the same. Okay? And then we want this trend to kind of be continuous. And if we plot F oil-based mud 0, it's going to look like this. Okay, that's for the assumption of oil-based mud 0. And if you use some crazy number like 60%, you're going to get a valley. It's going to go up like that. And then you might get a couple of points here. Unfortunately, this sample only goes out to C, the measurement only goes out to C21 or something, but you'll get something like that. So we're basically trying to graphically remove the hump, okay? And that's just put in a different number, you see the hump go away, you're there. Okay? Once you get this number, the correct number that kind of puts all these on a straight line, or not a straight line, but a kind of what you think is the correct number, okay? Okay, so that's for the number you're looking for. You still, unfortunately, have to calculate this, what the lab usually reports, on a C7 plus basis. So to solve this second problem, kind of the first part's okay, but getting FOBM is a graphical thing, but then you have to calculate that. So there must be some way to go from FOBM to this FOBM, whatever I called it, 7 plus weight percent. Or I think up above I called it, okay? There must be some link between the two. And you also need that link for the second problem. So you might as well figure it out and use it on the first problem. That's what Miss Marple would do. Poirot's a little different. He likes elegance. He likes to get the killer, but he likes to do it in the most complicated, because it makes him look better. Miss Marple's very, she's got this casual, she just likes to solve the murder. But Poirot, he likes to look good. Has anybody never seen the program with Poirot? Everybody know? You have to go on to Netflix. I mean, Poirot's a great guy. I mean, he's a little Belgium guy who is really, you want to hug him, but he doesn't want you to hug him, right? Miss Marple, you can hug her just like a grandma. Okay. So there is some link, and you can figure it out. Okay, I'm sure you can figure it out. So, and then the part B is simply that, once you figure this out, because what you are doing is that you're back calculating this. Once you figure it out, part B is done, right? You got it. So you get FOBM and part B graphically. And then you have to figure out how to get this weight percent C7 plus contamination level. All right, so that's all the tips and hints I'm going to give you. The rest you have to do yourself. And we'll take a break.